All right, Chapter 5 review, quadratic functions. No graphing calculator here, so everything we're going to do by hand. Let's jump right into it. I will try to break down my kind of game plan before we tackle each one. So this very first one, we're talking about vertex form. I can look at it. I can see the form that it's in. So remember what's inside the parentheses. This controls the left and right of the vertex, and it's the opposite of what you would think. So when I'm trying to make the vertex here, I know that it's a positive 4 in the x-axis. And then the back number is going to be your y value, and that stays the same. So we're moving right 4, up 5. So right 4, up 5. So there's my vertex. The negative sign in front tells me that this is going to open down. It's concave down. And there's no number there to stretch it. So remember the pattern that kind of gets played out? The pattern that gets played out is right 1, down 1, left 1, down 1. Right 2, down 4, left 2, down 4. And then it goes right 3, down 9, 6, 9. And then I can just kind of cheat and just kind of use symmetry to get the other one. So remember, if you really just want to do one side of it, you can kind of use this symmetry line here called the axis of symmetry, and you can just get the points on one side of the line and then basically just reflect those and get them on the other side of the line. And where the 1, 1, 2, 4, 3, 9 comes from, remember, is when you're talking about y equals negative x squared, for every move of x that's 1, your y is going to go down 1. But then when you have an x move of 2, you're going to drop 4. 3, you're going to drop 9 because we're squaring something. All right, later on we might stretch 1 and we'll see the effects of that change. All right, moving on down, number 2, similar idea. So here we're going to see a bit of a stretch. So same game plan. Inside here, I'm going to do the opposite. So on the vertex, it's going to be negative 3. And the back number is going to be the same. It's going to be negative 6. So there's my vertex. Left 3, down 6. Boom. And now from here, since it's a positive number, I know we're going to be concave up. So we're going to be moving right and up, right and up. But instead of going, my normal 1, 1 and my normal 2, 4 and 3, 9, what I'm going to do here is this 2 stretches it vertically. So all of these numbers get magnified by 2 for my heights. So when I do these dots, I'm going to go over 1 up 2. And I'm going to go over 2 up 8. And I'm going to go over 3 all the way up 18, which is going to put me off my graph, so I don't have to worry about it. And then I can just use symmetry over this line of over the line of symmetry here. And I kind of have like a skinny, a skinny parabola. It kind of goes like that. So I stretched it vertically because of that too. Next problem, number 3. What is the y-intercept? All right, before I even look at the problem after that, as soon as I see somebody want to know what the y-intercept is, I know that x equals 0. So basically they're saying, hey, find y when x equals 0. So when I put 0 in over here, I'm going to get 0 plus 2 squared added to 4. So 0 plus 2 is 2. 2 squared is 4. 4 plus 4 is 8. So correct answer here would be A. All right. Number 4, which of the following is true about that parabola there? So this is an SAT style question. No numbers, but you need to know what they mean. So the first thing is, looks like we're talking about vertex and opening up or down. Well, the easiest thing to see first is, since this is a negative, we're opening down. All right, we look like that. So that's going to wipe out A because it says opens upward. Wipe out the other opens upward. So now we're just trying to figure out the vertex. Well, remember the vertex is opposite of what's inside the parentheses, and then same is what's at the back side of the parentheses. So that tells me that the correct answer must be D, because this B is wrong right here. All right, number 5. Now we're moving on to the next section, which was standard form. So here's where we're jumping into 5.2 notes. And standard form is a little bit more work. So first thing you want to do is to find, you want to try to get the vertex. So that's first and foremost. But to get the vertex, we need to find x. And x is always going to be the opposite of b over 2a. That's my line of symmetry. That's the x component of my vertex. So we're trying to get this first part. So I do negative b, which it's already negative 6. So negative 6, that's positive 6. 2 times a, well, a is 1. So 2 times a is 2. So it looks like x is going to equal 3. So it looks like for my vertex part, x equals 3. And now to get y, remember this f of x is really the same thing as y. Now I need to plug 3 in for x and solve for y. So y is just 3 squared minus 6 times 3 plus 8. I probably should put that in parentheses just to be safe. 3 squared is 9, subtract 18 added to 8. And that's going to be negative 9 plus 8. It's going to be negative 1. So y equals negative 1. So I now have a vertex. So go right 3, down 1. It's positive in the front. My a is positive, so I know that we're opening up because that's a positive 1. And there's no number there to stretch it. So since a equals 1 in the front, and maybe I should just talk really quick. You know, a is the 1 in front of x squared. B is what's in front of x. And c is the constant at the end. So if a is 1, I'm playing the 1, 1, 2, 4 game that we've been doing, you know, all along. So 1, 1 over 2 up 4. And then I'm going to go over 3 up 9, which also I notice I could have saw right away that this was the y-intercept, because if I put 0 in for x, it wipes these out. So that back number in standard form is always the y-intercept. So just another way I could have got that. And now we graph it. All right. Moving on down, number 6 over there. For the given function g, what is the maximum value? So that means if I were to graph it, which I don't have to, but if I were to graph it, it's going to have a maximum. So I kind of know it must be a parabola like that. And just remember the maximum occurs right here at the vertex. And, you know, the vertex occurs at some xy. Well, the maximum is going to be at that y value. It's going to be at that height. So basically, I got to find the y part of the vertex. So I'm going to do what we just did a minute ago. First, I got to get the x part. So it's opposite of b over 2a. Well, here, a is negative 1. B was 4. C is negative 2, but we don't really need it. So negative b is negative 4 over 2 times a. Over 2 times a. And that just is negative 4 over negative 2, which is x equals 2. So I know that my vertex is at x equals 2, but that doesn't really tell me the maximum. I got to plug that in and get the y value. So y equals a negative. I'm putting a 2 in right here. 2 squared. Be careful on your parentheses. And because what I have to do is I have to do the parenthesis first. I have to do 2 squared is 4, and then just slap the negative in front. And then this is a positive 8. It's a minus 2. So that ends up being 4 take away 2. Looks like y is 2. So looks like the vertex is at 2, 2. So my maximum occurs right here at this y value of 2. So max and mins always occur at the vertex. You get that? You got a lot of information. So number 7 says in the xy plane, we have the equation y equals c for some constant c. So remember, constant means it's just a number. So we have some equation, you know, like y equals 4 or y equals -2. C is just some number. And we know that these lines are horizontal, all right? Y equals a number is a horizontal line. So some horizontal line intersects a parabola at exactly one point. Well, the only way for that to do that is either I'm just touching it on the bottom or I'm just touching it on the top. But that's the only way a line can intersect a parabola at one point. You know, normally the parabola comes down and you kind of hit it at two spots, the two zeros of the function or the roots. But on this one, it must be at the vertex. So I'm going to basically be trying to find the vertex of this function. And again, I'm looking for the y value because that's where it cuts through. So this equation, y equals x squared plus 4x, it's in standard form. If I want to, I can think of it like this. My back number is 0. So let's get the x part of the vertex. It's -b over 2a. So it looks like x equals -2. That's my vertex. And then I got to get my y value. So y means you stick -2 in for x. And 4 times -2. We don't really need the 0 because this was the original function. And what's that come out to be? Y is -2 times itself is 4. 4 times -2 is -8. So it looks like y is at -4. So there's the vertex. So if I were going to graph this, it's cutting through. So let me kind of just get rid of this to show you what's going down. So I have some sort of graph. And I know that the vertex is at -2, -4. So -2, -4. There's the vertex. There's a positive 1 in front. So I know it's going, you know, over 1, up 1, over 2, up 4, up 4. And it's going to look something like this. Well, the only way a horizontal line can intersect that is right here, once. And that line is at y equals -4. So really, once you get the vertex, you kind of have the answer right there. All right, number 8 says find the zeros of this function. So basically, that just means, hey, solve it for 0. Figure out what 0 is, or what x is when y is 0. So I plug 0 in. And now here's where you got to have some strategy, man. This is important. So this is a full trinomial. You know, I have x squared, I have x, and I have a number. When that happens, I'm going to try one of two things. I'm going to factor, and if I can't, I'm going to use the quadratic formula, which I don't want to because it's long, but I will if I have to. Now, if I were to look at this problem, and I were to just see an x squared and an x, and no number, chances are on that one, I'm going to GCF factor, okay? And then for both of these, I got to use what's called the zero product property. If you're factoring, you got to use the zero product property. Or the only thing left is if I have an x squared and I just have a number, and I'm missing the x part, well, if that goes down, I'm probably going to be able to do the square root of both sides. And you're going to see all of these cases play out. There's basically 4 cases. Complete the square, I never use unless I have to, which I think I'm going to make you do once on this test, just so I can say, hey, I taught you how to do it. But I don't see a ton of value in it unless you're doing equations of circles, which we're not. So let's try to factor this. So I notice a is 1, so this should be an easier factoring one. So the game is find 2 numbers that can multiply to make 24, but those same 2 numbers have to add to make -2. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. It's the only ways to make 24. Well, the only way to add and get a -2 out of this would be this combination right here. So that would multiply to make -24. It would add to make negative 2. So I'm going to have x plus 4 and x minus 6 equals 0. And here's where I'm going to apply the zero product property. And all that property says, this is basically all ZPP says. It says if A times B, if two things time together to equal 0, then either A equals 0 or B equals 0, or both. So we just got to find out, when is this parenthesis right here going to be 0? Well, it's going to be 0 when x is negative 4, because negative 4 plus 4 is 0. And this one is going to be 0 when x equals a positive 6. So usually your zeros are going to be opposite of whatever your factors are. All right, number 9. Jump into that one. So I notice on this one right away that it looks a little bit different than the other ones. And I wish I wouldn't have erased that. But up over here in the right-hand part of the screen, what I'm seeing is I only have x squareds and I only have numbers. So this tips me off. I think I'm going to do the square root of both sides. So what I would do is I would first isolate the x squared term. So first thing I'm going to do is divide by 4. And I get x squared. Now normally you'd punch that in on your calculator, but this is the no calculator section. And I did this for a reason. I know that 4 doesn't go in there evenly, so I don't want you to try to do division by hand. But I want you to leave that as a fraction, because when you take the square root of both sides, to get rid of that squared on the x, I square root it. So that just gives me x. And then remember, anytime you take the square root of something, it's the plus or minus. But I chose two numbers that were perfect squares because remember, you can break this up into the square root of the top and the square root of the bottom, which is really friendly. It's just 7 over 2. So our answer is positive or negative 7 halves. Or you could say x equals 3.5 and x equals negative 3.5. All right, so those are your two answers. So that one's just taking square roots. All right, number 10 says solve. Well, this is a little trickier solve one because I'm looking at it and it's got all three pieces. X squared, it's got x's, it's got numbers. So I'm going to try to factor. So my two options here for me normally are either factor or hopefully not quadratic formula. So if I'm going to factor it, I need to set it equal to 0. So that's my first move. So I'm going to add 8x to both sides. And when I do that, I get 3x squared plus 8x plus 4 equals 0. And I'm like, oh crap, a is not equal to 1. Right here's my a. So I'm going to have to use the bottoms up method. And we've learned this earlier in the chapter. So the bottoms up method works like this. I basically multiply a times c, and I drop it. So I just got x squared plus 8x. Well, 3 times 4 is 12. All right, so I've changed the problem. Like it's kind of illegal right now because I'm not allowed to just do that when I want to. But it's going to work itself out here in a minute, so bear with me. So factor like normal. The ways to make 12 are here. And the only way to get an 8, I believe, is to add these two together. So you're going to get x plus 2, and then you're going to get x plus 6 equals 0. And now because we did bottoms up, all right, and I need to undo what I just did, like you're not allowed to just multiply 3 by 4, I'm going to divide by that 3. I'm going to divide by that a on both pieces. And what I get is, now normally if this was factoring, if it was just factoring, I try to simplify, and if I can't, this side right here would have been 3x plus 2, and then the one on the right would have been x plus 2, and that's how you factor it. But if I want to use the zero product property, I'm going to leave it as x plus 2/3. This one I'm going to get x plus 2. because when I want to use ZPP, something times something equals 0, I want to find out when the parentheses are 0. I think it's a little easier to see that this parenthesis is going to be 0 when x is negative 2/3. And this one is 0 when x is negative 2. It's a little tougher to see when this is going to be 0. You basically have to do some algebra, and you end up with this exact same thing over here. So you kind of chase your tail in a circle. So when you're solving, you don't need to go all the way with bottoms-up factoring. Number 11, this is kind of a little fact that write a quadratic in standard form. So we need to put it in this form if we know the zeros. So it's kind of like working backwards. So I'm going to kind of go, say we know the answers. We know the answers, x equals 5 and x equals negative 3. Well, we can work backwards just like what we just did. So the 0, the factors must have been a minus 5, and the factor must have been a plus 3. All right? So these are the zeros. These are the factors. And then I can multiply the factors out to get the actual, it's supposed to be a q, the actual equation. I can just kind of do my normal multiplying here. And this is just x squared minus 2x minus 15. So there was the original equation that gave me those zeros for answers. So it's just kind of going backwards. Number 12, which function has 4 as its only 0? Well, if 4 is my only 0, that means x minus 4 is the only factor. Well, that's not x. This one, that's not the only factor. This one's not the only factor because I do have that, but I also have this x here, so it can't be u. This one is the correct answer because j of x, you don't see that a whole lot, is x minus 4 times itself. So yes, x minus 4 is the only factor. SAT likes that type of question as well. Number 13, looks like we have a good old projectile motion problem. We've done a million of these. Baseball player hits the ball toward the outfield. The height of the ball can be modeled by, so, you know, to boil that down, basically if you put this into a chart and you were to graph this, now you can't do it here because we're not allowed to use a calculator, but if we were to just do the seconds and we were to plug in any value for seconds, this will calculate the height. So at 0 seconds, if I stick a 0 in there, I'm going to get an answer of 3. So that means at 0 seconds, right when I start the stopwatch, the ball is 3 feet high. And that makes sense because in our equation, the 3 represents the initial height of the ball, or where I hit it with the bat. Okay? Initial height, or the height that I hit the ball. Now the 50, so remember 50 represents, this was h sub 0. V sub 0, well, this is the initial velocity, okay, aka how hard I hit the ball, or my bat speed, how quickly I swung the bat, knocked it out of the park. And then the negative 16, well, this is gravity. If we're talking feet per second, which we are, and this only works on planet Earth because gravity is different on every planet. If we were doing meters per second squared, it would be negative 9.8. All right, there'd be a negative 9.8. Actually, check that. There'd be a negative 4.9 because you got to do half. Been a while since I've had a physics class. I think 1995 was my last physics class. But who's counting? All right, keep going. Number 14, I'm looking at this and I'm thinking, well, I don't see, this is just a squared problem. I know I can get rid of that little 2 if I just take the square root of both sides, I can get rid of that squared, and it's just going to leave me x plus 3. And square root of 25 is just positive 5 and negative 5. So now I have two equations to solve. When is x plus 3 equal to positive 5? And then when is x plus 3 equal to negative 5? And I get an answer of 2. And I get an answer of negative 8. So you kind of like it when you don't have to factor, you don't have to use quadratic formula. All right, number 15, probably the least used method of what I showed you in this chapter. Completing the square. So completing the square, the first thing you want to do is you want to get these two on one side, and you want to get all your numbers to the other. So I'm going to have x squared plus 8x. I'm going to leave a big space here, because I know with completing the square, I have to put a number in there. And I'm going to subtract that 17 from both sides to get negative 7. Now, completing the square, what it means is a perfect square is when you have the same dimensions, like x plus 2 times x plus 2, or for short, x plus 2 squared. And when you multiply all that out, you get x squared plus 4x plus 4. You know, if this was x plus 7 squared, you would get x squared plus 14x plus 49. So what happens is this number, it doubles in the center, and then it squares by itself for the end. So that's kind of what always happens. So I want to make that happen. I want to be able to solve it like I just did number 14. So what I'm going to do is I'm going to chop this b part right here in half, and I'm going to square it, and I'm going to put it right here. Now, to keep the equation balanced, if I add 16 to this side, I have to add 16 to this side to keep everything still balanced well. So on the right-hand side, I'm going to get it positive 9. Well, on the left-hand side, basically what I'm going to get if I factor this is I'm going to get x plus 4 squared. Because see that pattern? I had the double and I had the squared. So now it's just like number 14 was. Now I can just take the square root of both sides, and I'll just have x plus 4 equals positive or negative 3. So x plus 4 equals 3. X plus 4 equals negative 3. And that gives me a negative 1. And it also gives me a negative 7. So two answers there, completing the square. All right, number 16 says, see, so I see all three pieces. I'm like, all right, I got an x squared, I got an x, I got a number. So I try to factor it. And I got 1 and 12, 2 and 6, 3 and 4. I don't think there's any way to get this negative 2. There's no way to get that. So this is not factorable. Crap. So this means I got to use the quadratic formula. So remember, quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. So who's my a, b, and c? A is 1, b is negative 2, c is negative 12. So I'm going to get rid of this factoring stuff because we don't need it. So let's put our numbers in and let's see what we got. Well, negative b, or opposite of b, so that's positive 2. B squared, negative 2 times itself, 4. Subtract 4 times a times c, all over 2 times a. So we clean this up and we get 2 plus or minus the square root of 4 plus 48, or 4 minus a negative 48, but still going to be plus, all over 2. Keep going, some housekeeping. 2 plus or minus the square root of 52, all over 2. And now's where I want to try to simplify that square root of 52 if I can. So to simplify, I'm going to factor tree it. 2 and 26, 2 and 13. I believe that's as low as I can go. So pair of 2's count at once on the outside. If there were more, I would multiply them together, but there's no more. 1 loner on the inside. So I think I can replace that square root of 52 with 2 radical 13. And now I need to break these two up. So now I have 2 divided by 2 plus or minus 2 radical 13 divided by 2. And these cancel out and become 1. These just cancel out. And this is the number. That's the exact answers to number 16. No imaginary, so we were lucky there. Number 17, I got a feeling we're going to see an imaginary one on this one. So let's do it. First thing you want to do is you got to set it equal to 0. So I got to add 3 to both sides. I'll go a little quicker on this one. So x squared plus 2x plus 3 equals 0. Try to factor it. There's no way to get positive 3 and a positive 2 when you add. So can't factor it. So negative b plus or minus square root of b squared subtract 4 times a times c all over 2a, which turns into negative 2 plus or minus square root of, well, that's 4 take away 12, which is negative 8 all over 2. Now, we learn how to fix whenever you have a negative under a radical. Basically, all you're going to do is you're just going to make that radical positive, and you're going to put an I at the backside. Now, the behind-the-scenes move was radical negative 8 is the same thing as radical 8 times radical negative 1, but mathematicians have defined this, and they say, hey, we're just going to call that I. So we just substitute the I in. I don't think I can simplify this anymore because there's no number in, or actually I can. Check that. Radical 8 we can work on. That's 2 times 4. 2 times 2. So pair of loners, or pair of count at once, a loner count at once. So I can tighten this up a little bit. This is negative 2 plus or minus 2 radical 2 i's all over 2. Break it up. Cancel some stuff out. That's a negative 1. And there we go. And that's a complex number because we have imaginaries, we have reals, so we're all good in there. Last problem, SAT style problem. Basically, we gotta get 2 answers, and we need to match up what we get inside and outside, and then they're gonna want us to add those together. So this is gonna be a quadratic formula. Can't factor it. So negative b plus or minus square root of b squared minus 4 times a times c. So 2 plus or minus the square root of, that's 4 plus 4 is 8, all over 2. We just simplified radical 8, so I'm going to cheat and use that from the last problem. This ends up being 1 plus radical 2. So it looks like my n is 1, my k is 2, so n plus k, 1 plus 2, final answer to this problem is 3. All right, hopefully that helps you out, and that's what you can expect to do on the no calculator portion of the test. See you.